Hi, everyone. My name is Tom Van Norman. I'm one of the co-founders of the ICS Village. Today, we're talking with Dragos and Garland Technology on gaining visibility into your critical infrastructure. Before we get there, a little bit about ICS Village. For those who don't know, ICS Village is a nonprofit organization founded by Bryce and Bort and myself. Throughout the year, we have a conference that we hold called Hack the Capital. We have our own podcast out there. We do presentations like this with our sponsors. All around, we're in industrial control system security, industrial control systems. What are they? How they work? Our main purpose is education and advocacy on everything around control systems. So with me today, we have Mark Lennon. He's the Director of Marketing at Garland Technologies, and Josh Carlson, the Senior Business Director at Dragos.
Thank you, Tom. Excited to be here today to talk about critical infrastructure. At Garland Technology, we are focused on providing packet visibility to security and monitoring tools with the industry's most reliable network taps, data diodes, and network packet brokers. We're always excited to work with partners like ICS Village and Dragos to help try to solve today's visibility and cybersecurity challenges.
And hi, everybody. Josh Carlson. Pleasure to be here. I'm super excited to be supporting ICS Village and working with Mark on the Garland side. And again, we provide the cybersecurity solutions for OT environments, really focused on asset visibility, threat detection, and incident response and procedure capabilities from that perspective. So looking forward to talking through three different specific use cases today that hopefully you guys find practical and that you can take and use within your environments today.
So I'm going to show you the industrial control system range that we take around to different conferences we use for different events. It is made up of all technology that you typically find in a manufacturing facility, or could be really any facility that uses industrial control systems. When this was designed and put together, I wanted to make it so it was real hardware. It was fully operational.
So what we have here, we have an industrial control system range. In the back, we have a water tank that has about 12 gallons worth of water in it. We have a 3-phase motor and pump that pumps the water from down here up through different sensing elements such as a flow meter, a temperature transmitter, and it goes into a tank where we have a level transmitter and a high level switch in there. So this is our cyber physical part of the display. What we have over here is we have various PLCs from Allen Bradley, from Phoenix Contact, from Siemens. We have security appliances from Phoenix Contact and Fortinet. This whole system is fully operational. So if we go over here to our human machine interface, we can go and change our level set point. We see our variable frequency drive change. We see our level go. We're going to start going to alarm. Now all of this stuff is done with actual hardware. And let me turn that off to lower the noise a little bit. And we're going to go into alarm because we did reach our high level. There we go. All of these technologies communicate over an Ethernet network. In order to bring that Ethernet network into some sort of a monitoring system such as Dragos that we're looking at today, we go through a Garland tap. The Garland tap down here, we're taking several of these devices, we're feeding it through it, and then the output of that is part of the feed into Dragos's network.
Thanks, Tom. And as you can see, the ICS Village range really helps illustrate the different components of a typical control system network. So today we're focusing on gaining visibility into a system like this and how to overcome challenges you may face. First, I want to quickly review some visibility foundation basics before we dive into the use cases. So to gain visibility into your network, there are two main components to remember. One, you need access to your traffic, and two, you need a security platform like Dragos that can take that data and analyze it. So to access your network traffic and provide packet visibility to a security tool, you have two options: a network tap and a span or mirror port on your switch. And as you can see in this diagram, the tap sits in between two network appliances, like your switches and your routers, and it creates an exact copy of the traffic. The span, if it's available, is a programmable port on the switch that mirrors the traffic to your destination. Adding a network tap ensures you are getting complete data to your security tool, as span ports are known to drop packets, create duplicate packets, and even introduce bidirectional traffic. Not exactly the foundation we encourage for OT security, as span wasn't developed for continuous monitoring. So keep in mind, network taps also provide traffic aggregation, regeneration, unidirectional secure traffic, as well as media and speed conversion. These are purpose-built to make it as easy as possible to instrument your security and monitoring solutions, so take advantage of them. Scenario one is a common situation where you may be adding a security or asset inventory solution to a legacy system. As you know, control systems were designed with reliability in mind, not necessarily transferring data to a monitoring destination, as many of these systems can be decades old. So maybe you're faced with an environment where the legacy switches do not even have span availability. So how do you connect the tool? How do you get the packets? And the easy solution for that is a network tap. Josh, you guys are running into this pretty often on legacy switches, right?
Yeah, no, absolutely. And so when we get to, one of the first things that organizations look at is, the need for security. And they say, well, we don't have budget. We don't have the capability to just simply, upgrade and replace every single thing within our infrastructure. But that doesn't necessarily mean that we don't want the security pieces, that asset visibility, that threat detection and things like that. And so from our perspective, the way that we look at this is saying, hey, it's super important for us to be able to get a top-down, view of everything that's happening within the environment, which includes getting down, if you kind of look at this diagram here from a Purdue model perspective, saying, yes, it's important for us to be there at level 3 and kind of see the operations and the different systems that exist within that, which is typically a little bit newer, upgraded a little bit more often. But then when we get down into that kind of level 2, level 1 environment, that's exactly what you were saying, Mark, is that our customers are saying, look, my OEM has said, we cannot just simply turn on the span ports, or the switches and the infrastructure that we used is, 7, 10, 12 years old and really can't support that from a resourcing perspective. And so we're challenged with, how can I get the visibility if my OEM or the switch infrastructure is saying, you can't make modifications, you can't change the configuration that we're here, otherwise you're going to lose some of that reliability, you're going to lose some of those safety features and functions. And so that's where partnering with solutions like Garland make a huge difference, because we're not modifying that infrastructure, we're not making changes, and some of the great physical capabilities of the devices and the solutions they bring to the table allow us to say with confidence, we can plug into those unmanaged switches or those switches without that technology, where they can span out and stuff. And we can use that tap to get the visibility that we want. And again, still provide a very safe, very secure, very reliable infrastructure for that plant or that facility to continue to function. So again, very, very cool, and allows us to do exactly what we're looking for, get them on their cybersecurity journey.
All right, now what we're going to do is we are going to look at our network topology, how we are gaining network visibility with the Garland device. So what we have down here is all of our network cables running in from our various devices. They all go down, connect to a switch. The switch does not have the proper spanning features that we need. So we have a Garland tap down here that we are running devices through. The output from the Garland tap is going to a Dragos sensor. From the sensor, it's going to be uploaded to a what they call a site store. From the site store now, we're going to see our assets. So currently, we do not have any assets shown on our screen. What's going to happen when we activate that, or when we start sending traffic to the Dragos sensor? We're going to start seeing assets coming in. So we're going to start gaining our network visibility. From there, we're going to be able to draw our network topology maps. We're going to be able to see what assets we have on the network. We're going to be able to see some IP addresses, some MAC addresses, some metadata, things like that. Josh will go into much deeper detail with that once we start having the assets populate.
So this is the Dragos platform that we talked about. This is the asset visibility, threat detection, and response platform that we have deployed here within the ICS Village. And as you can see, this is a fresh, brand new installation. We have no assets, we have no communications, we have no nothing. If you want to think about how this is deployed, we have the Dragos site store deployed within level 4 or level 3. Sometimes people do, if you want to think about it from a Purdue model perspective. And then we have the Dragos sensor also sitting at level 3, and then another Dragos sensor sitting down at level 2. The challenge is, though, as you can see, that we have no visibility of the network or the systems that are communicating inside that zone because, again, situation number 1 that we've talked about during this presentation is the systems itself are old, they're legacy, they don't have the resources within the switch gear, or they just don't have a span port capable, or our OEM has prevented us from making any of those types of changes due to safety or reliability concerns. And so what we're going to do is we're going to implement the Garland tap that's going to be in line between the two networks, and it's going to replicate all of that traffic out of a single port, securely delivering that to the Dragos sensor, and then we'll be able to see that traffic coming into the Dragos site store here. So now that we've connected the Garland tap to the infrastructure here, we have the ability to start seeing a lot more assets and a lot more of the details that we were looking for without having that tap in place. And so now that we have that tap there, and again, we didn't make any modifications to the switches, we didn't make any modifications to the process control environment itself, we can start to see that as these assets begin communicating, we start to see some of that traffic flowing in. We start to see, kind of basic information about the asset, total count, the IP addresses, things like that, who's doing the majority of the talking within the network infrastructure itself. So you can kind of get some ideas and figure out things that you want to look at there. So again, that's a great way for us to get kind of an initial set of data sets. We can then look at those assets in more specific detail. If we want to just click down here to our assets, we can start to, figure out if we have the ability to see it passively over the wire, what the host name is, what the type of device it actually is, what we would classify it as, IP address, MAC. And we can also set up some rules that will put those devices into specific zones. And so the zones actually come into play very nicely when it comes to mapping those assets into our environment, with the ability to say, either in a structured environment, or I can also look at it from an Explorer map view perspective, and I can start to see, okay, great, here is my process control environment. These are all the assets that exist within that process control environment, based upon their IP addresses or host names or types of controllers, and which of those assets are communicating out into the DMZ and things like that, and make sure that it's only those assets doing what they want. So again, regardless of what type of solution we're looking for, or what type of situation we're trying to solve for, whether that's a legacy environment where we cannot do any modifications, we can't span the traffic out of the switches, or the switch infrastructure just won't do it for whatever reason, or we may have a situation like we talked about in scenario 2, where we need the ability to see the assets, but we don't have the ability to deploy a bunch of Dragos sensors across the environment. So we use the aggregation, whether that's tap aggregation or span aggregation, into one Garland device, and then I use that one Garland device to feed the Dragos platform. And again, we can get all of this great information. And with that basic level of information through the assets, we can then start to get notifications around detections as far as threats or things that we would perceive to be threats. We can also look at different types of vulnerabilities. So as you saw, we went from basically zero visibility of the system and the infrastructure itself. And now we've got that list of assets. We've got that list of systems. We're starting to build a baseline of how those systems are communicating, the network infrastructure that they're using, the ports, the protocols, and all that kind of stuff. And we'll also start to be able to then analyze that traffic for various different types of threats and anything like that, or anything that we perceive to be malicious, whether that would be an insider making changes outside of a configuration window or anything like that. So again, and why this is important to you is you go from not having any visibility, simply trusting what the OEM implemented, and kind of the static diagrams and different things like that you've been using to catalog, what assets I have, how those assets, are supposed to be communicating. And now you have a checks and balances system in place where you have the capability through Garland to be able to get that visibility from those various different network devices, see how those systems are communicating, establish a baseline, and then set up some notifications to say, if these things change outside of my normal operating parameters or procedures or time windows or however you kind of manage your system, you can then go from there and look at that. So awesome way to take a legacy environment and say, this is something I can not make any changes to, do this one simple configuration change. And now all of a sudden you're getting significantly more visibility into the environment. Again, still looking at it from that top down perspective. So thanks again, Tom. Appreciate you showing us how that works.
The next scenario we wanted to discuss is another common situation where you may be faced with adding a security solution in a distributed network, where the location and the distance may present access challenges. We also wanted to discuss, what do you do if you have to rely on span? Maybe your physical location doesn't support additional hardware. So in these situations, an aggregator tap allows you to aggregate the traffic from various locations to a central sensor, as well as ensuring your span link is unidirectional and secure.
Yeah, so this has been, again, another common challenge, especially when you see, kind of the key word here is distributed, right? You've got geographically dispersed networks in a variety of different critical infrastructure environments, such as water, mining, power could be, right? If you're talking about distribution and transmission networks, you could also look at some of the different things around manufacturing and stuff like that. So I've got all these distributed networks, or all these different points where I'm doing some type of process control, I'm doing some type of manufacturing or something like that, and I just don't have the capability to permanently add big or different sizes of network architecture into those environments. It could also be a situation where you're dealing with like hazardous material, and so the devices where the monitoring and all of that kind of stuff is being done are just not rated to sit inside of those environments. But the good thing is that you have that all coming back to one centralized place. So as Mark was saying, there's a couple of different ways that we could architect this out. The first one, as depicted in this diagram here, is where we actually leverage all of the span ports. So we're taking all of the span traffic, feeding it through the infrastructure into a centralized egress point, and we're aggregating all of that traffic here through one of the Garland devices. And that helps us out tremendously, because now I take one device, I aggregate traffic from 4 unique locations into that one specific device, and then I feed that information out to the Dragos sensor. It does kind of that pre-analysis work there right on the sensor, and then it sends that metadata over to the Dragos site store, which again is where all of your kind of main reporting and notifications and things like that are happening. So a great way to do that. Again, you're not really affecting the infrastructure too much. You're using some span, so you are using some resources on the switches and things like that. But another way, if that was not an option, that we could redraw this infrastructure is to actually tap, like we were talking about before, and use this device as an inline. So if you had a bunch of fiber runs where all of these different sites were coming back into one centralized place, we could actually tap in from a fiber perspective into those, be an inline, again, very passive, very safe, very easy to do, and do the same type of thing. So we wouldn't be using span ports in that case. We would just be another inline tap, and we would have just the 4 different places where we could plug in. And the great thing with Garland is they've got a variety of different solutions that allow us to say, well, maybe I've got more than 4. Well, that's fine. We can, double the switches themselves, or the devices, excuse me, themselves. Or we've got even bigger devices than that, where we can aggregate tons of traffic and do different types of packet brokers and things like that, or maybe we don't need certain types of traffic. We just want to kind of parse that out, do a little bit of pre-parsing before it's assembled and then sent over to the Dragos platform. So again, a couple of different ways to look at this, but very, very cost effective. Awesome when you've got a situation where you can't deploy, 4 different Dragos sensors into those different environments for whatever the reasons that Mark kind of listed out there, or some other reason. And then, but again, you still need that visibility. So a great way to solve the challenge ahead of you from a security perspective, but also minimize the impact to the environment overall.
So now we have our network traffic being fed to our Dragos sensor with the Garland Technologies tap down here. We can see all of our assets populating on the screen. We can see different things about the assets, the names, the IP addresses, the MAC addresses, things like that. We can see our different things such as our firewalls, our PLCs, our network switches, our HMIs, our human machine interfaces. All that stuff appears now in our asset inventory. Some of the other things that we can see. We have a map now that shows all of our assets. And none of this was available before because we didn't have network visibility. Over here, we see more and more data being available due to our Garland tap being installed. We truly do see all of our network assets.
Thanks, guys. So you may be asking, where do you start? How do you put these pieces together and quickly gain visibility into your network right now? With any selection process, you probably need to meet a series of requirements and regulations, and then design and implement a detailed security architecture. We get it. So we wanted to walk through a quick proof of concept scenario that we hope helps ensure you address your end goals and helps you get up and running before a full deployment.
Yeah, and this is one of those scenarios where you have, organizations who are looking to evaluate and kind of do a side-by-side, right? I mean, they issue an RFP, they've got a bunch of technical specifications and things that they hope to solve with these different pieces of technology. And, but, like me, I want to see it, right? The proof is in the pudding. I want to put these two solutions up against each other. And I really want to see apples to apples comparison as I'm starting to see that. So how do we do that? Well, again, you might have a environment that you're using for patching, right? If you're a NERC CIP compliant type of architecture, you say, hey, I have this spare architecture that's very closely replicating my production environment. And I want to be able to go through and use that environment because it's so closely replicating my full production environment. And I'm going to run some traffic through it. And again, here we could do it a couple of different ways, thanks to the versatility of the Garland solution. We could span and do a span aggregation similar to what we talked about in the other architecture. In this case, we're spanning off of 2 different switches. And so anything that's moving east or west, north or south in that Purdue model architecture there would be fed into the Garland device, aggregated, and then multiple of the solutions can receive that exact same data. And so then you can go through the user interface of those solutions and you can say, hey, who detected the most assets, right? How much information was there, as Tom was saying, do I have the IP addresses, MAC addresses, operating systems, applications, vulnerabilities? Am I seeing the threats the way that, we're kind of pushing them through the system here? Am I seeing the set point changes or different, configuration uploads and downloads and things like that? And so what am I able to detect? What am I able to see? Again, doing an apples to apples comparison. The other thing you could do, again, because of the flexibility of the Garland devices, is be able to tap in this situation. So again, maybe you say, hey, still don't really want to trust or rely on SPAN because of, one reason or another. This is another unique situation where you could reconfigure the Garland device to be a tap inline, connect the cables passing through, and again, that same traffic would be replicated out to those different types of solutions. And the amazing thing is, this doesn't only work for our technology, which is doing the visibility, the threat detection and the response. You could use this for a lot of different things. And this could also be one of those scenarios where, hey, this starts your first level of training for people who say, this is how we're going to go deploy it in our production environment. So getting those folks not only up to speed on this technology, but maybe some other technologies that could leverage this information, but also give them an opportunity to kind of see, hey, when you get to the field, this is how you need to configure these switches, or this is how you need to connect this Garland device. This is what you should expect to see in your asset visibility threat detection platforms. This is how we're going to kind of zone and conduit and, fix these things so that they match our security architecture and design. So great opportunity, again, to say this is how a proof of concept can work, and make sure that what was cataloged in the RFP as a response will in fact do what they say it does inside of your actual infrastructure today.
So we'd like to thank you for watching. We hope this helps you gain visibility into your critical infrastructure environments. I'd like to thank Tom and ICS Village for hosting us today and the work that they're doing educating on OT security. Josh, thank you and the Dragos team for your expertise and insight into asset visibility and threat detection.
Thank you for doing this webinar with ICS Village. Appreciate both Dragos and Garland taking the time to record this and put it out there for everybody's viewing pleasure.
And I just echo Tom's sentiments. Thank you so much for taking the time out of your valuable day to listen to this. Hopefully you found this helpful, and it helps you overcome some of the technical hurdles and challenges that you've been faced with of, moving from a legacy environment into a full asset visibility threat detection solution. Hopefully one of these diagrams or network architectures kind of sparked a few things in your mind to set you down a path of success. So good luck, stay safe. Appreciate you taking the time.
We know this is a very important topic for many of you, so if you're looking to learn more, please visit the ICS Village, Dragos, and Garland Technology websites. There's a lot of great information there. And if you want more info on the deployment scenarios that we discussed today, please follow the QR code or the link below for the Dragos Garland Technology Joint Solution. Thank you for your time.